Assalamu alaikum guys, welcome back. This is lecture 14 of our AS chemistry crash course and probably the last topic of the chapter moles. Okay, moles chapter is basically the last chapter of moles. Okay, the last topic. Percentage yield is a topic. In the previous video we completed percentage purity, okay, and all the formulas basically related to percentage purity, and before that we did the empirical formula and molecular formula calculation, and even before that we did all the formulas which are related to moles. Okay, now percentage yield, the last topic of this chapter, basically percentage of product which is formed in a chemical reaction. Before I explain this, you must know what yield actually means before going into percentage yield. Yield is actually the amount of product which is formed in a reaction. So yield is just the amount of product, the product which is produced in a chemical reaction. Percentage yield is actually the percentage of the product that you actually get from your experiment as compared to the product that you expect to get from the experiment. Okay, because there are several limitations of the experiment, there are several errors, impurities and other stuff that limit the amount of product that we get. Okay, so before we move on to the definition or the calculations of percentage yield, there are a few terms that you guys should know. Okay, so first of all, theoretical yield. Theoretical means in theory. You can calculate it on paper. Okay, it is basically the maximum amount of product that you can get from your reactants, given that your reaction is taking place under ideal conditions. Okay, just the calculated amount, that you could calculate using a paper and a pencil, that would be obtained if this reaction takes place under perfectly ideal conditions. Okay, the maximum product, the products that you could calculate using stoichiometry and moles and everything. Okay, now but in reality we don't get our theoretical yield, rather we get our experimental yield or our actual yield. Experimental yield, which is also called the actual yield, is the actual amount of product due to the different limitations of that reaction. Okay, so the amount of product that is actually formed in the reaction, and this is if this experiment is taking place under perfect conditions, which is very difficult, then the maximum amount of product that you will get is gonna come close, very close to the theoretical yield. But usually the experimental yield is most of the times less than the theoretical yield. Okay, the amount of product that you calculate on paper, the amount of product that you get in your laboratory, there is a difference in between them. The experimental yield, the laboratory yield, is less than the one which you get on your paper. Okay, so it is less than the theoretical yield usually. Now let's look at the formula for calculation of percentage yield. The percentage yield uses both the experimental yield and as well as the theoretical yield in our calculation in the formula. And this experimental yield, the data of experimental yield, will always be given to you on the exam paper, okay, in the question, because experimental yield is not something you could calculate yourself, right? It has to be performed in an experiment, and then that experiment has to give you a data, and that has to be the experimental product. Whereas theoretical yield is what is actually required to be calculated, and this is the major portion of the calculation, okay, where most of the students get stuck. Okay, so now let's look at the formula for percentage yield. This is the formula for calculation of percentage yield. Percentage yield is equal to experimental yield, basically the lesser yield divided by the greater yield, the theoretical yield, okay, multiplied by 100 to convert it into a percentage. Okay, the units must be the same for both of them. Okay, if the experimental yield is given in moles, then the theoretical yield must also be kept in moles. If the experimental yield is given in grams, then the theoretical yield must also be kept in grams. Okay, now this is an example that involves the experimental yield and theoretical yield that should be taken in grams. Okay, so, or you could convert both of them in moles, it's up to you. Now let's read through the question. 1.92 grams of magnesium was heated in excess supply of oxygen. Okay, so we are reacting this much grams of magnesium with oxygen. This is the reaction. So magnesium is combining with oxygen and you are expected to get magnesium oxide. 3 grams of magnesium oxide was obtained. What is this? 3 grams was obtained. This is the product that is obtained in this reaction. So can I call it the yield of the reaction? Yes, I can. And what type? The experimental yield, because this is what the examiner is telling you, that this was obtained in that particular experiment. Okay. Calculate the percentage yield of this magnesium oxide. So the experimental yield has already been given to you, experimental yield for magnesium oxide, and now all you need to do is calculate the theoretical yield first and plug it into this formula and you get your answer. Now this is the equation that you need to use. You've been given the mass of magnesium, right? Mass of magnesium, and first of all you need to calculate the theoretical yield. Now listen very closely and very carefully. Theoretical yield is the one that you get on after calculation of moles and molar calculation. So if you have the mass of magnesium and you calculate the moles of magnesium, you can use this equation to calculate the moles of magnesium oxide, and once you do that, you can convert the moles of magnesium oxide into grams. That will be your theoretical yield. Okay, or once you get the moles of magnesium oxide, you can convert the moles, these moles, this mass which is given to you, can convert this into moles and then plug it into that formula and get your answer. Now this example that I have done, I have kept it in grams. Okay, I've kept this in grams and I've converted the value of magnesium oxide that is obtained in grams. So now let's look at it. The moles of magnesium that I get, they are to be calculated using the formula given mass upon molar mass, right? Atomic mass of magnesium. Mass of magnesium is 1.92 grams divided by 24. So I got this moles, this many moles of magnesium. 0.08 moles of magnesium are obtained. Now if you look at the mole ratio is 1:1, because in front of both of them there is no coefficient written, so that means the coefficient is 1, right? So mole ratio is 1:1. So that means the moles of magnesium are the same as the moles of magnesium oxide, right? So moles of magnesium oxide are also 0.08 moles. Now I've gotten the moles of magnesium oxide. From here I can do two methods. I can either keep this in moles. This is my theoretical yield. Okay, theoretical yield, this is my theoretical yield. Theoretical yield. Now I can either leave this in moles and convert the 3 grams also into moles and plug it into this equation, or I could convert the moles into mass and then I could use that mass to and plug it into the equation and get my answer. So I'm going to convert this into mass. For mass, I can use the formula moles multiplied by mR of magnesium oxide, because it's the mass of magnesium oxide that I'm calculating, right? So the moles 0.08 multiplied by the mR of magnesium oxide, which is going to be the mass of magnesium plus the mass of oxygen. Mass of magnesium is 24, mass of oxygen is 16. When you do your calculation, put it into your calculator, you'll get an answer of 3.2 grams. 3.2 grams is also the theoretical yield, okay, but in grams. This was the theoretical yield in moles, this is the theoretical yield in grams. Now once you've got this in grams, you also have the experimental yield in grams. Just plug it into that equation. The experimental yield divided by this theoretical yield multiplied by 100. See, the experimental yield is less than the theoretical yield even in this example. So 3 upon 3.2 times 100 and you got your final percentage yield of this product, 93.8%. And this means that the product, this reaction was quite efficient, because this much of the product has been obtained, very little has been wasted. Okay, so this was the entire lecture about percentage yield, and this pretty much brings us to the end of the chapter moles, and this is literally everything you need to know about moles. But guys, remember, the theoretical portion of moles is just 50% of moles preparation. The remaining 50% needs to be completed from your past paper practice. Okay, and moles is a calculative portion. It's just like math. The more you practice, the better you become at it. The less you practice, the worse you become at it. So please do practice. Okay, and from the next lecture, inshallah, we are going to start out a new chapter, most probably chemical bonding or inorganic chemistry. Any one of these two has to be started in the next chapter, inshallah. Thank you so much.